Hello everyone, I'm Faisal Hussain, currently studying mechanical engineering at London South Bank University. Today, we're gonna cover matrices, the basics of matrices, and a way to solve linear equation using the inverse method. So there will be around 5 lectures on matrices that will come up in future. So before starting, I hope that matrix is one of the easiest mathematical tools that you will ever face in your engineering career, right? This is very simple, but the uses of this matrix, they are huge. With some of the students, they learn matrix, but they really don't know about its applications. So today, at first of this video, I'm gonna tell you why we need to learn matrix, and then I will show you some relevant maths on it. So yeah, let's get started. As an engineer, why do we need to learn matrices, right? So for example, when we have uh, very big equations and let's say they are huge in number. For example, you are an engineer and you want to analyze some force at a large at a particular point in a bridge. Hmm? And then those forces are unknown to you. So what are you going to do? You will derive, or let's say you will find some data and set up some sorts of equations, right? And now at this point, let's say you get thousands of equations and now you need to solve it. Don't you think it's a bit messy type thing, right? And you need to be a bit organized in your professional life. So matrix will help us to do that. So here we can see this type of equation like 2x1 plus x2 equal to some sort of constant, and then you will reach up to thousandth time of equation. And look, this is not an organized process. So with the help of matrices, we can make those equations organized and solve them very easily. So this is the matrix form AX equal to B. So A is basically the main matrix, the numbers are X. These are those unknown quantities. You really don't know about those equations, right? So these are the unknown quantities. You can say it as the coefficients, and B is basically the known value, which you already know. Let's say from the bridge example, you already know some sorts of value. So those values will go into this B section. So that is how we solve these big equations, and then we find a result from it. Next, let's say in computer or software application. So as an engineer, we run, let's say, CAD softwares or any simulations. And these softwares, they are heavily rely on matrix calculations. So for example, this is a particular object, and these are the boundary conditions, the roller, and then there are some nodes, and you're applying load on it. But now, how computer will gonna solve this? Because let's say there are thousands of elements in this particular object, right? And for thousands of elements, the equations will be like that, so many equations. And for that reason, computer, the machine uses matrix process to organize the whole system, and then he gives you a particular result for that simulation or any design. And yeah, let's say in circuit analysis, in real life, you can see that a circuit can contain hundreds or let's say thousands of components and nodes. So it makes the circuit more complicated, right? But if you use the matrix, so for example, even in your engineering career, let's say you're solving a circuit and you're using KCL or KVL, right? And with these two process, you have, for example, 20, 30, or 50s of equation, and you need to solve it. So how are you going to solve it? If you use the matrix, it will help you to solve the equations uh, quickly or in an organized way. So yeah, that is how we can use matrices as well. Even if you use MATLAB, you can easily solve thousands of equations by using matrix. So I would recommend that. Then image, let's say. Here you can see a picture of Mona Lisa, but there is another scene behind it. So for example, let's pretend this is a smaller version that has 5 by 5 pixels, okay? And this is the 5 by 5 matrix. So there are some reasons behind those numbers I'm going to tell you now. So computer, they mainly sees millions of numerical values arranged in a grid. So simply like this, kind of. So this grid can be represented as a matrix. And if you want to change, for example, if you want to change the brightness of a particular picture, for example, this 100, you can see, I assume that this 100 is responsible for the brightness of the picture. Now, if you want to increase the brightness, this 100 will go up. Let's say it will become 120 or 150, for example. Again, if you want to rotate the picture 90-degree, or if you want to turn it left, or like a mirror, or if you want to rotate 180-degree, so definitely the metrics, these numbers will change their position. So behind the picture, that's how the metrics work that we didn't consider in our real life, but this actually happens. And then in mechanical or in robotics, if you learn some of the things in robotics, like how robot arm moves or any joints, robot joints, they actually use this type of matrix form and they use trigonometry with that. So you can simply solve those type of problems using matrices. So that is how we use matrix as an engineer. So it's a very powerful tool. Now, we're gonna learn about linear equation. So what is a linear equation? Linear equation is a type of equation that has a power of 1 and that follows y is equal to mx plus c, and it will provide you a straight line curve, not a curve, a graph. So uh, why do you need to learn linear equation in order to learn matrix? Basically, matrix works with simultaneous equation, and you need to understand the linear equation first in order to solve those simultaneous equation. Now I'm gonna show you some basics of matrix, like how we add or subtract those, let's say 2 or 3 matrices. So these are very easy. If you can see, these two are matrix in a matrix form, and you want to add them up. So what we're gonna do? So this 4 and this 1 will add together. So 4 plus 1, similarly 2 plus 8, then 3 plus 9, and similarly for them 5 plus 3, then 7 will go with 5, and 6 will go with 4. And ultimately you'll get this type of result. So these are quite simple, and that will be similar case when there will be a subtraction. You just want to subtract them, and then you'll get an answer. Next, we need to multiply matrices. So for example, if A is this matrix and B is this matrix, and we need to find AB. So how are we going to find it? So we're going to multiply it. So this 1 will go with this 8. So 1 times 8 plus this 5 will go with this 2. So as you can see, first row will go with this first column of the second matrix. Similarly, 1 will go with 4 and 5 will go with 5, right? So as you can see, So what will happen here? So 1 times 4 is 4 plus 5 times 5, 25 anyway. So you'll get this something like this. Similarly, 1 will go with 3 plus 5 will go with 8, and then 1 with this, 5 with 6. You'll complete this first line of this matrix. Similarly, for this second row, you will do the same operation. So second row will multiply with this first column, then second column, third column, and then fourth column. And then this final row will be multiplied with this first, second, third, and fourth column. And that is how you're going to solve this multiplication. And then you will get a particular answer for it. This is very easy, and I know you know this. This is just like a brush up matrix, right? So next, we learn some terms of inverse matrix. So before that, we need to understand two things, minor and cofactor, right? So for example, for this question, we are told to find the inverse matrix. So how are we going to do it? We need to find the determinant first. So for this matrix, the determinant is 9. And one more thing, if let's say the determinant of a matrix becomes 0, then there will be no inverse. So keep in mind. So we have 9 here, is not equal to 0. So we can find the inverse matrix of this particular matrix. Now, I have written here A1, 1. 1, 1 means this first one, this means row. Second one means column. So first row, first row, first column. So first row, this one, and first column, this one. If you eliminate these two things, what you're going to have? 2 minus 1, 4 minus 2. And then you will solve this, you will get 0. Then A, 1, 2. 1, 2 means first row, this one, and second column, which is this one, 1, 2, 4, this column. You're going to eliminate this, and look, here, this is a cofactor. So in matrix, let's say a 3 by 3 matrix, the first sign, let's say 3, this would be plus, second one would be minus, third one plus, so it will go like this. So I keep it in mind like this. Let's say 1 plus 1. If you do 1 plus 1, it will give you an even number, right? So when you have even number, there will be plus. And when you have odd number, for example, 1 plus 2, which is 3, right? So 3 is an odd number. And for odd, you will insert a minus. So that is how I remember. So if you want, you can try that as well. So yeah, so for 1, 2, you can find this. For 1, 3, that means first row, third column. So first row and third column will be eliminated. So you will have 5, 2, 1, 4. And yeah, you will get 18 from here. Similarly for 2, 1, 2, 2, 2, 3, and then the rest of the things, you can easily find this. After that, we're gonna change the matrix. So that is how we're gonna change the matrix. So we have those values of A1, 1, 1, 2, 1, 3, and the other stuffs. And then you will insert the values on here. And then we need to do the transpose of the matrix. So that is how we transpose it. So this row will become column. A column when you transpose a matrix. So be careful on that. And similarly, this 11 will shift its position to here, and 3 will take its position here. So that is very simple, but be careful on that. Now we need to find the inverse. So that's the formula, adjoint A divided by the determinant. So the determinant was 9 and adjoint, so this is the whole form of the adjoint matrix. And ultimately, this is your final answer, which is the inverse matrix of A. Now, there's a short technique. For example, if there is a 2 by 2 matrix, A, B, C, D, any matrix, and you want to find the inverse matrix of that. So that's the technique. So 1 divided by the determinant of that matrix. And on the bracket, so this D will go up here, minus B, minus C, and A. So try to keep it remember because it's going to save your time a lot when you solve some equations using inverse technique. But make sure that the determinant is not 0. If it's 0, then there will be no inverse matrix, right? Now, we're going to solve some linear equations using the inverse method. So before that, I told you one thing. The matrix form is AX equal to B. And when, let's say, a matrix A is invertible, we can multiply both sides by its inverse to get X, right? So we'll get ultimately X equal to A inverse B. Now, for example, we have been told to solve these linear equations using the inverse method. So how are we going to solve it? First of all, we will write the matrix form, okay? So the matrix form is AX equal to B, and this is A. So this one is A, which is we'll take the numbers first. So 5, 2, minus 3, and positive 4. So this is A completely. X, we really don't know the values of x1 and x2. So these are unknown to us. So these are unknown quantities. So we'll write x1, x2 will be in the third bracket equal to B. B means the constant that we already know or already given in the equation. So 19 and minus 27. So that is how we're gonna set up this matrix format. Now we're gonna find the determinant. So because we are using the inverse method, so determinant is required to find the inverse matrix. So yeah, the determinant would be 26. How? So 5 times 4 is 20. So minus would be plus, then 3 times 2 would be 6. So 20 plus 6 would be 26. And then we'll find the inverse matrix. So first step was matrix format. Second step is inverse matrix. So inverse matrix, we use that technique and we'll plot this data and we'll get something like this. So this is the inverse matrix of this equation. And now we need to find the values of x. So which is x equal to A inverse B format. So that's how we're going to solve it. So x1 and x2 would be on the left side of the equation, and on the right side, we will use this inverse matrix, so which is this one. And then we're going to multiply with the constant, the B, which is 19 and minus 27. You can multiply it, you will get this result, and ultimately you will get two values for x1 and x2. So which is x1 is 5, x2 is minus 3. So yeah, that is how we can solve a linear equation using the inverse method. In the next week or next video, we're gonna show you some other techniques to solve those equations in different methods. So till then, keep watching and thank you very much for your support. Hope to see you soon. Bye.